welcome to all. This is myself, S.A.E.C, Assistant Professor, Department of Mathematics, S.A.E Engineering College. Today I am going to give lecture about the S.A.E test for independence of attributes. First we see what is the S.A.E test. The S.A.E test, very powerful test for testing significance between the theory and experiment, was given by Professor Carl Pearson 1990. The uses of the S.A.E test, to test goodness of fit, to test independence of attributes, to test population of variance. Among the three uses, today I am going to deliver the lecture about independence of attributes. So the three major properties for the S.A.E test. The property number 1, the mean of the S.A.E distribution, which is equal to the number of degrees of freedom. The second property, the variance of the S.A.E test, which is equal to the double the number of degrees of freedom. Third one, the S.A.E distribution curve approaches the normal distribution. The curve, as the degree of freedom will be increases. These are the three major properties. Now we'll go and discuss the S.A.E test for independence of attributes. So what do you mean by independence of attributes? The S.A.E test for independence is a statistical test used to determine whether there is a significant association between the two categorical variables. It checks whether the distribution of the one variable independent of the distribution of the other variables. So if you want to go in the independent cases, we need to follow the following steps. The step number 1, state the hypothesis. The hypothesis is nothing but it will be statement. So initially we need to assume it depends on the nature of the problem. So first one, the null hypothesis, this is the notation H naught. The two variables are independent. So next one, alternate hypothesis, which will be denoted by the symbol H1. So this is opposite to the H0 statement. That's why there is a two variables are different. Or maybe you can assume it, you can write it, two variables are not independent. So both will be same. Next, step number 2. Create a contingency table. Let us consider two attributes A and B. So A is divided into two classes, B is divided into two classes. Clearly A is divided into two classes, A is a one class, B is another class. B also be divided into two classes, C is a one class, D is another class. So since it be 2 by 2 contingency, it becomes to only the 2 row. Suppose it be 3 by 3 contingency, it becomes to A attribute, B attribute, C attribute, depends on. Here also we need to include the column like as A, B, C. So which is, it's not necessary to get as a square contingency, maybe the non-square also be applicable. So next procedure, next step we need to go. Okay, so A and B, it will be row total A plus B and another row total C plus D, as well as the column total A plus C, column total B plus D. So capital N is nothing but the total frequency. Capital N is a total frequency, which is sum of the all A value, B value, C value and D value, A plus, B plus, C plus, D. It will be called as total frequency. So next we need to calculate the expected frequency to each cases of the A, B, C and D. So why E of A which is equal to column total value A plus C multiplication row total value A plus B in this numerator divide the total frequency of the capital N, which is the expected value of E. Next one, expected value to the B, expected value of B, which is column total B plus D multiplication row total A plus B divided by capital N, as well as E of C, C for the column total A plus C. So C to the row total C plus D, the numerator divided by the capital N, which is a total frequency. So D for expected value of the D, which is column total B plus D and row total C plus D divided by capital N, the total frequency. So again, when you add in this row wise, we need to get the A plus D value, the first row, second row C plus D value, as well as the column wise A plus C value, and column wise the second column B plus D. Again, if you sum in this, the finally we need to tally the capital and the total frequency. Next, step 4, compute the chi-square statistic. So we need to find the what is the chi-square value. To find the chi-square value, the chi-square statistics is calculated using chi-square, which is equal to summation O minus E whole square divide E. So O is nothing but observed frequency and E is nothing but expected frequency, which is nothing but this is A value, B value, C value, D value. This is observed frequency. So corresponding value to the E of A. Okay, E of A value, E of B value, E of C value, E of D value, which is nothing but expected frequency. So observed frequency minus expected frequency whole square divided by E. So the all value sum, it will be, we can get the calculated value. So after getting the calculated value, we need to choose the degrees of freedom. So the determine the degrees of freedom, which is the degrees of freedom are calculated as R minus 1 and C minus 1. R is nothing but number of O is given the consistency table. C minus 1, C is nothing but number of column, it be given the consistency table. So suppose it be given only one row and second row 1 and row 2, as well as column 1 and column 2. Clearly in this be given the 2 rows and 2 columns. So if you want to get the degrees of freedom, which is 2 minus 1, there is also 2 minus 1, so it becomes to 1 into 1 be equal to 1 for the degrees of freedom. Using the degrees of freedom, we can able to find the table value. So compare with the critical value. So using the chi-square distribution table, compare the calculated chi-square value with the critical value at the chosen significant level. Okay, it will be 5%. So 5% means it will becomes to 0.05. So which is not fixed. Suppose the question be discussed 10% or 90% or 2% or 1%, depends on it will be changed. Suppose the question is not given, generally we could assume it will be 5% level or 1% level. So why the general cases I chosen here the 5%. So 5% means 5 by 100 it becomes to 0.05. So now next we can get the conclusion based on our calculated value as well as the table value. If calculated value that is the chi-square value, which is a calculated value, chi-square value be calculated value. If calculated value comparing the table value is lesser, then the initial assumption H0 null hypothesis will be accepted. Suppose the calculated value is greater than comparing the table value, then the H0 will be rejected or H1 is accepted. We can get the conclusion. What is meant by table value? These are the chi-square distribution table. So column is be given the degrees of freedom up to the 100. Have to be 100 be given. So degrees of freedom 1, 2 level, 3, 4, 5, 6, 7, 8 it be given. So row wise it be given. Row is be given as a percentage, which is 1% level. 1%. 1 by 100 it will becomes to 0.01, which is 2.5%. It will be 2.5 divided 100, it will becomes to 0.25, which is 5% level of significant. So 5% means 5 by 100 it will becomes to 0.05, which is 10%, which is 90%. So it will be going on, which is 95%, 97.5%, 99%, 99.5%. So the maximum of the problem will be used in this percentage of testing only for the 5% level or 1% level. The remaining of the value will be used. So it will be given means we need to go and check according to the given value. Okay, now we go for the example number 1. So the following table gives the classification of under workers according to the gender and nature of the work. It will be discussed in the gender and nature of the work. Test whether the nature of the work is independent of the gender of the work. So we need to check whether it will be the nature of the work with the gender, it will be independent or dependent. So before going to the problem, we need to identify, okay, whether the given is a chi-square independent test or not. So clearly we could able to understand this. So by the word it will be given independent. So which is identification for chi-square test. So another identification, it will be given 2 by 2 consistency table. This is a 2 by 2. So this only the value, these are the total, which is a column total, this is a row total, these are the value. So clearly which is a 40, that is in the position of A, this is in the position of B, the position of C, this is a position of D. So clearly which is, so 2 by 2 consistency table, this is also identification for this is chi-square independent attribute type. So clearly the row wise A plus B, so row total 40 plus 20 60, second row total 10 plus 30 it will be equal to 40. So column total 40 plus 10 it will be equal to 50. So another column 1 20 plus 30 it will becomes to 50. So as well as finally how to tally this, the total frequency n value. So the row wise and the column wise, when you compare the row wise and the column wise, we may add, we need it to be satisfy the total frequency. Now we'll be assuming it. So now we'll be assuming it H naught. So already I said the H naught is nothing but we need to assume it depends on the problem. So what is the discuss in the problem? The problem we discussed gender and nature of the work. So gender and nature of the work, it will be independent or not. So why I like to assume it. Let us assume gender and nature of work are independent. So the initial assumption H naught we need to assume depends on the discussion of the problem. I mean otherwise the favor of the problem. So next we need to assume this is step 1 H1 alternate hypothesis. So alternate to the H naught statement. Therefore both are not independent or both are dependent. It will be not independent or both are independent. That is a step 1. So next one, the step 2, we need to find it the expected frequency. We indicate the expected value of the A, B, C and D. So expected value of the A 40. Expected value of 40 clearly which is equal to row total value into column total value. 60 into 50 divide will be frequency. Total frequency 100. So clearly the two zeros will be get cancelled. Remaining are 6 5s are 30. Here will be expected value of the first one. Next one expected value of 20 which is equal to row total, either the row total or column total. Row total 60 into column total 50 divide total frequency 100. So we could cancel the numerator denominator, remaining 6 5s are again the 30. It will be second expected value. Third expected value to the 10 which is equal to column total to row total or row total into column total. Okay, both will be valuable only. So I like to take for first one column total 50 into row total it will be 40. Row total 40 divide the total frequency 100. Total frequency 100. Again we could cancel it numerator denominator the zeros. Rest of the cases 5 4s are maybe 20. So last one expected value of 30. Expected value of the 30 again the column total into row total. 50 into 40 divide 100. It will be total frequency. Clearly, the 2 zeros will be get cancelled. The numerator denominator, remaining of 5 fours are 20. So clearly we have the expected of 40 and 20, both are the 30. The expected value of 10 and the expected value of 30, both we have 20. So using by the observed frequency, observed value and the expected value, we could be able to find the chi-square table. Observed value 40, 20, 10, 30. Expected value 30, 20 and 20. Now observed minus expected, observed minus expected, square. Last one, observed minus expected, square, divide expected. So the observed frequency the given question 40 and 20, 10, 30. The expected frequency just before we get the value 30, 20. Now we could find observed minus expected. Observed 40 minus 30, 10. 20 minus 30 minus 10. 10 minus 20 minus 10. 30 minus 20, which is a plus 10. So now observed minus expected whole square. 10 square as 100. Again minus 10 square also be 100. So minus 10 square also be 100. Again there is a 10 square be 100. So now observed minus expected. Now observed minus expected, square, divide E. So first one. First one, observed minus expected, it will be 100, divide E. Expected value 30. Clearly the 0 will be get cancelled. If you get cancelled, it becomes to 3.33 be going on. So for more numerically, we could take the only the 2 position of the value. So again the next one, 100 divide 30, that is also becomes to 3.33. So next one, 100 by 20. 100 by 20, the 0 will get cancelled, which also becomes to 5. So 5.00. 5.00. Again 100 by 20, it will becomes to 5.00. Now we need to add all value. The chi-square formula. Chi-square equal to summation observed minus expected square divide expected, which is equal to sum of the value, which is equal to sum of the value 5 plus 5 10, 10 plus 3.33 13.333, 13.333 plus 3.333 16.66. So which is calculated value. It will be calculated value chi-square. Okay, this is step number 3, which is step number 3 to get chi-square value. Next step number 4. Step number 4, we need to find the degrees of freedom. So here degrees of freedom for R minus 1 and C minus 1, R minus 1 to C minus 1 at 5% level of significance. So clearly the number of rows will be given in this problem 2, therefore 2 minus 1. Number of columns given in this question, that is also 2, it will be 2 minus 1, which is equal to 1 into 1, it will be equal to 1. it will be equal to 1. So the degrees of freedom for 1 at 5%, it will be equal to 3.84. Already I shown the table. Okay, if you look in the table, we can get degrees of freedom for 1 at 5% level of the test. We could fix the 3.84. It will be from the table value. Now we need to compare with the table value and calculated value. So clearly the table value is a lesser than comparingly the calculated value. Otherwise we could say calculated value is greater than the table value. Calculated value is greater than the table value. Therefore it will be H0 will be rejected, because it will be calculated value 16.66 and table value 3.84. Already we discussed in the procedure. Comparatively, the table value, the calculated value is bigger means. So initial assumption H0 is rejected. H0 will be rejected. So clearly we can get the conclusion from the problem. So both gender and the nature of the work, both is nothing but not independent. That is both is nothing but definite, because H0 is nothing but rejected. Now we can go to the next example. So on the basis of the information noted below, find out whether the new treatment is comparatively superior to the conventional one. So we need to check, okay, the both one. We here also how to identify. Before the problem we need to identify whether it's a S.A.E.C test or not. So clearly we could identify it will be that the two attributes. One attribute is nothing but treatment. One attribute is nothing but it will be treatment is comparatively superior to the conventional one. So it will be superior case 1, it will be conventional case 1. So the conventional case and the new cases. So it will be discussed on the two cases. So clearly we could check it will be a independent node. That will be one identification. Second identification, it will be given 2x2 contingency table. This is also identification for this is S.A.E.C test. So as well as we could also compare with, we could also check it with this row total. It will be given, the both row totals will be given, as well as the both column total will be also given. So row total 40 plus 70, 110. So 60 plus 30, it will be becomes to 90. The column wise 60 plus 40, 100. Column wise second column 70 plus 30 will be 100. So finally the total frequency capital N, it will be becomes to 200. That is also identification for that is a S.A.E.C test. Okay, now so based on the S.A.E.C test, the initial step what will do will be assuming this hypothesis cases. Hypothesis is nothing but statement. So initially will be assuming null hypothesis. So null hypothesis notation will be called as H0. So we need to assume it depends on the discussion of the problem. Okay, the statement we need to assume it depends on the problem. So that's why I assumed it here, no difference between the two treatment. So the two treatments are the conventional treatment, new treatment. So both are the independent. Okay, that's why I assumed it. Next one, H1 is nothing but alternate to the H0. So therefore there is a difference between the treatment. Already I said H0 and H1 is nothing, both are the different. H1 is nothing but parallel to the question. H0 is nothing but opposite to the question. So depends on the calculated value and table value. Finally we could get a conclusion. Okay, the step 2. So already we know. Okay, will be find the expected frequency are given in the table. So first one. So we need to find the expected frequency to the each observed cases. So first observed cases is a 40. First observed cases of 40, clearly which is a row total into column total divide 200. So if it is cancelled 0 0, it also be 0 0, the both will be get cancelled, and 1 time of 2 which is 5 time of 2. So 5 into 11 is nothing but 55. So second one, second was expected value to the 70. Expected value to the 70. Again, the column total into row total divided by total frequency. This is a n value. So clearly 1 0, it will be 0 cancel. One more 0 will be cancel. So clearly it will be 1 time of 2. 1 time of 2, it will be 5 time of 2. Which is 5 time of 2. So 5 11s are, it will becomes to 55. So third one. Okay, third one, again the column total 100, the row total 90, the 0 0 both 0 we get cancelled. So 1 time 1 number of 2, 5 number of 2, 5 9s are, it becomes to 45. So again the 2 zeros will be get cancelled, and 1 time of 2, 5 time of 2, 5 9s are, it will be 45. So after getting the expected value, also we need to add in the row wise. So row wise 55 and 55 both will be sum 110. 110. The same manner the second row 45 plus 45 need to get as a 90. So not on the row wise, the column wise also 55 plus 45 it will becomes to 100. So again 55 plus 45 it will becomes to 100. Finally when you total in the column wise and the row wise, how to satisfy the total frequency. And clearly 110 plus 90 is a 200, 100 plus 100 B also becomes to 200. So now we have the expected frequency as well as observed frequency. Using the both one, okay, we could find the chi-square value. So clearly observed becomes to be O. So 40, 70, 40 and 70 and 60 and 30 it will be given. We could form as a column. So expected frequency we get. So in this corresponding to the observed frequency, 40 will 55, and whether it's a 70 it will be equal to 55. When it is 60, that is a 45. When the observed will be 45, 30, that is the expected is a 45. So now already we know that. So next step to find observed minus expected square. So clearly observed 40, expected 55, 40 minus 55 minus 15 square plus 2 to 5. Plus 2 to 5. Again 70 minus 55 plus 15 plus 15 square 2 to 5. Next one 60 minus 45 it will be also plus 15 square 2 to 5. 30 minus 45 minus 15 square, so 2 to 5. Now finally we need to do chi-square for observed minus expected square divide expected. So observed minus expected divide expected. So 2 to 5 divide 55. 2 to 5 divide 55. Therefore we could cancel by 5 table. This is a long times of 5, which is in this 8, 4 times of and 45 times of. So if we cancel the 11 and 45, we could get 4.091. So we could also use in the calculator, and finally we can get. So again the 2 to 5 divide 55 dB becomes to 4.091, and 2 to 5 divided by 45 will be get exactly it becomes to 5 times. Again the 2 to 5 divide 45 we could get exactly this also 5. So we need to sum the value, that is a chi-square formula, nothing but sum of observed minus expected square divide expected. That's why it becomes to the 18.182. So this is a calculated value. This is a calculated value. Now we know from the 2 and calculated value. So already we have in the calculated value. So now we need to get the table value. So clearly the calculated value becomes to 18.182. So tabulated value of the chi-square. So tabulated value of chi-square for r minus 1 and c minus 1. So already we know the r minus 1. R is nothing but number of rows in the given problem. Number of rows in the given problem. C minus 1 is nothing but number of columns in the given problem. So clearly in the given problem the number of rows are 2 and the number of column also be 2, because it will be given 2 by 2 consistency table. So according to the formula, the degrees of freedom 2 minus 1, 2 minus 1, it will becomes to 1. 1 into 1 move 1. So for 1 degrees of freedom. So previous problem also we discussed, we taken for the 5% problem of the second weekend. So already I said, suppose the question is not given, okay, which level of the significance we need to test. Generally we could choose 5% of level or 1% of level. So I chose it here, the 5% of level of the significance. So from the table value, already I shown the table, okay, already I said also the maximum will be used in the 5% level or 1% level. So the 5% level of the significance level, the table value, the degrees of freedom, one is nothing but 3.84. This is not a picture, difference on the 3 degrees of freedom, the value also will be differ. Okay, difference on degrees of freedom, difference on the percentage level of the significant, the value will be differ. Since it will be 1 and 5% level, the value is nothing but 3.84. Now we can get the conclusion. Now we have table value as well as the calculated value. Now we could compare. Since the calculated value psi square had be given, had be calculated previously 18.182. So the table value just now we get, that is the psi square equal to 3.84. Comparing the table value, calculated value is bigger. So therefore clearly we reject the null hypothesis H0. Null hypothesis H0. Therefore hence we can conclude that treatments are not independent. So both are the dependent. Both are the dependent. So given the following table for air color and eye color, find the value of psi square. Find the value of psi square. Is there good association between the two? So already I said, before going to the problem, first we need to identify whether the given problem is a psi square of independent type or not. So how to identify the independent type? We need to check it will be given the two attributes. So one attribute is nothing but air color. There is a one. Another attribute is nothing but eye color. So clearly which is attribute A, which is attribute B, which is attribute B. So and one more also be given, the table as a brown. So blue, gray and brown, that will be given in this eye color. Air color is given fair, brown and black. Okay, now that is also given. So that is also identification for chi-square independent types of attributes. So already I said the 2 by 2 conditions is not a picture. Maybe the table 3 by 3 or 4 by 4 or n by n or non-square cases also will be applicable to test in this method. So the compare the two more problem. Okay, third one is a different because it will be given 3. Okay, which is a 3 by 3. 3 by 3 consistency table. So whether it's a 2 by 2 or 3 by 3 or n by n as well as the non-square, okay, everything is the same rule only. So clearly which is observed 15, 5, 20, 20, 10, 20, 25, 15, 20, these values are observed value, observed frequency. So already said, before going to the problem, first we need to check whether the given total, row total is correct or not, as well as the column total are correct or not. Suppose to be not correct, we couldn't go in this method. So 15 plus 5 is a 20, 20 plus 20 is a 40, first one be correct, second one 20, 10, 20, also 50, second also be correct, third one 20 plus 15, it becomes a 40, 40 plus 20 is a 60. So row be not a problem, as well as the column wise also, 25 plus 15 is a 40, 40 plus 20 is a 60, again 15 plus 5, 20, 20 plus 10 is a 30, so 3 20s are, it will be 60, so 60 plus 60, 120 plus 30, 150, as well as the column wise. Column wise 60 plus 40, 100, 100 plus 50 is a 150. So which is be called as capital M. This is value of A, this is a B, this is a C, it will be D, E, F, it will be given. Okay, so we could take as A, B, C in this different attributes. Okay, so already know that initial step we need to assume, depends on the problem, we need to assume the hypothesis. Hypothesis is nothing but statement. So H0 is nothing but null hypothesis. So here we are discussing in this cases of the air color and eye color. So I assumed here the two attributes air color and eye color are independent. So we need to assume the null hypothesis prior to the question. So next one, alternate hypothesis, it will be opposite to the null hypothesis. That's why I assumed here the two attributes are not independent or dependent. Clearly, so before going to the table values, first we need to get the expected value. So expected value to the 15. expected value to the 15, expected value to 15. So there is a column total into row total divide total number of frequency. So clearly the 1 0 will get cancelled. 1 0 will get cancelled. After the simplification of the case, it will becomes to 16. So expected value of 5, it will becomes to 8. Expected value of 20, it will becomes to 16. So expected value of 20, that is a column total into row total divide. So total number of frequency be 20. So expected number of 10 also we know it will becomes to 10. Expected value of 20 becomes to 20. Expected value for the 25, 24. Expected value to the 15 also it will be 12. Expected value for the 20 it will be 24. Already know how to find these cases. So finally we need to check the all value 16 and 8 and 16. Okay, when you add it will becomes to, it will be 40. So again we need to add in this 20, 10 and 20, it will becomes to 50. So 24, 12 and 24, it will becomes to 60 in this row total. As well as the column total, 16 plus 20 plus 24, it will becomes to 60. As well as 8 plus 10 plus 12, it will becomes to 30. 16 plus 20 plus 24, it will becomes to 60. So finally when you add the row total and the column total, so the total frequency, the capital N ought to be satisfied, which is know that is observed frequency, which is expected frequency, which is observed minus expected square. This one observed minus expected square divide expected. Okay, this is the procedure. First one observed, it will be given the table value 15, 5, 20, 20, 10, 20, 25, 15 and 20 is given. That is corresponding expected value 16, 8 and 16, 20, 10, 20, 24, 12 and 24 by the previous table. We could find now observed minus expected. 15 minus 16 minus 1 square as it will be also plus 1. Again 5 minus 8, so 5 minus 8 is a minus 3, minus 3 square as a plus 9. So 20 minus 16, it will becomes to 4, 4 square as a 16. 20 minus 20 becomes 0, 0 square is a 0. 10 minus 10 0, therefore 0. 20 minus 20 becomes a 0, 0 square also be 0. 25 minus 24, it will becomes to 1, 1 square as a 1. 15 minus 12 becomes to 3, 3 square as a 9. 20 minus 24 becomes to minus 4, minus 4 square as a 16. So finally we need to find observed minus expected whole square divide expected. So clearly 1 divide 16 becomes to 0.0625. Maybe you can use a calculator, you can able to find the value. So next one 9 divide 8 it becomes to 1.125. 16 divide 16 becomes to 1. 0 by anything so becomes to 0. Again 0 by 10 also becomes to 0. 0 by 20 divide becomes to 0. So 1 divide 24 0.042 and 9 by 12 becomes to 0.75. 16 divide 24 becomes to 0.666. If you sum the value, that is a psi square is nothing but summation observed minus expected square divide expected. Okay, no. So if you sum the all value, we can get 3.6455. This is calculated value. Now we know that what is the procedure to get the solution. So now we need to find the degrees of freedom. Degrees of freedom, it will be also not given the percentage. So we will be assuming the 5% of level. Generally the problems are not given the percentage, will be assumed 5% or 1%. In this problem I assume the 5%. So before to go in this case, we need to find what is the degrees of freedom. 3 minus 1. Why be 3 minus 1 is nothing but number of rows given the problem 3. So it will be 3 minus 1. So number of columns are given the problem so 3. Therefore 3 minus 1. So clearly 3 minus 1 becomes to 2. Again 3 minus 1 becomes to 2. 2 into 2 becomes to 4. So which is nothing but 4 degrees of freedom at 5% of significant. So already shown the table. If you check it in this degrees of freedom, the fourth column, in this fourth column, okay, at the 0.05. Okay, the value will be matched with the 9.49, which is a table value. Already shown the table. So which is table value is nothing but 9.49. So already said the degrees of freedom is not fixed, depends on the problem, nature of the problem will be differ. So the values also be not fixed, so depends on degrees of freedom, depends on testing significance, the value also will be differ. Now we have the calculated value as well as tablet value. Now we can get the conclusion. So clearly the calculated value is nothing but 3.6455 comparatively table value, which is a lesser than. Okay, it will be lesser than. Since it will be lesser than value, we could get the conclusion. Hence, the air color and eye color are independent. Okay, both is nothing but not a different. Therefore, it will be H0. H0 is accepted. H0 is accepted. Okay, now that is the conclusion to the problem. So, now we can go through in these problems. We have the 5 problems. So 5, first one, which of the distributions is used for testing of hypothesis? So the testing of hypothesis, so now we discussed normal distribution, which is not in a testing of hypothesis. Normal distribution, which is not a testing of hypothesis, and gamma distribution, which is also not a testing of hypothesis, Poisson distribution, which is also not a testing of hypothesis. Previously we discussed the 3 cases only: one, goodness of fit; another one, independence of attributes; and population variance. That cases only it becomes true in the testing of hypothesis. Therefore clearly which is a chi-square distribution. Okay, chi-square distribution only, which is a testing of hypothesis, because here only we introduced in this hypothesis cases H0 as well as H1. That's why the answer is a B. Okay, that is a very simple only. Okay, directly we could get the answer. Second one, that is also important one. So which chi-square distribution looks the most likely a normal distribution? So initially we discussed, I given the 3 major properties of the chi-square. The property number 1, the mean of the chi-square, it will be equal to number of the degrees of freedom. The variance of the chi-square, it will be equal to double the value of the degrees of freedom. So last one, when it be increasing the degrees of freedom, the chi-square distribution curve will be approaches to the normal. That's why you see that first degrees of freedom is a 4, 5, 6 and 16. Comparing these values, the 16 is a more value. If it goes more than 12, we could get it goes in this normal distribution. Therefore clearly the chi-square distributions looks the most likely a normal distribution when it goes for high level of the degrees of freedom. Therefore D is answer. That's why which is a comparatively these 4, that is a 16i, that is a D. Okay, next one, third one. 1000 students at a college level were graded according to their IQ and economic conditions. So clearly here the IQ 1 and economic conditions 2. These both are attributes. This is a A, that is a D. So both are the different attributes. That is identification for chi-square distribution. So of the ohms, what would be the expected value of the rich based on the IQ level of, eye level of IQ from this table. So that F of objective types, so we need to observe the question clearly, what the question be based on the question be asking. So clearly here they are asking the question something but only expected value. The question be asking in this only the expected frequency of rich based. Rich based is nothing but here the rich based on the eye level. Eye level is something but this is the eye level. Rich based this row, eye level this column, both are matching the value something but only the 460. Only the 460. So which is a rich based and high level from this table. So they are not asking in this chi-square, they are asking only for expected frequency. So we need to find expected value to the only the 460. How do we know that? What is that? Expected value of 460 by the formula something but column total 700 into row total, which is a column total to the height. Okay, 460 for the row total, which is a 600 divide, this is a capital N, that is a total frequency 1000. Clearly we could cancel 2 zeros and 1 zeros also. Now will be get 6 answer, it will be 42 with a 0, 420. Therefore clearly in this objective the 420 is the answer, that is a D. So we need to check first, before the problem we need to check what the questions are discussed, whether they are asking in this chi-square or whether they are asking in this expected frequency. So clearly the answer is nothing but 420. Next one, problem number 4. Find the value of chi-square. But here they ask the value something but directly only the chi-square value. Here they ask the value only the chi-square, not in this conclusion. Only they ask in the value something but chi-square value. So it will be given, okay, from the cases that will be given the chi-square means, okay, based on the table we could get the conclusion which is a independence of attribute case. So it will be row total, the 2 row total, 2 column total, anyway, whatever it is. So what is the table? Observed frequency and expected frequency, observed minus expected square and observed minus expected square divide expected. This is a table. So observed value 620, second observed value 480, third observed value 380, fourth observed value 520. It will be record the expected. We could find expected of 620, which is equal to column total into row total, 1000 into 1100 divide total frequency value. So clearly the 2 0 we get cancelled, 1 0 we get cancelled, which will be 50. So clearly 5 11s are 55, 1 0 it will be 550, which is nothing but expected value to the first one. Second expected value of 480. So column total 1000 into row total 110 divide 2000. So clearly 3 0 will get cancelled and here will be 50, the same answer as the previous 550. So third one, expected value to the 380, which is equal to column total 1000 into row total 900 divide 2000. So clearly the 3 zeros will be get cancelled and it will also get cancelled 450. Expected value of 520. Column total 1000 and row total again 900 divide 2000. If it is cancelled, it will also becomes to the same answer, previous answer. Okay, no. So now we have the expected value. The expected value of the 620, 550. 550. The expected value for 480, 550. Expected value of 380, 450. So expected value of 520, 450. Now observe minus X factor square. So both we need to subtract it. So 620 minus 5550, 70, 7 sevens are 499. So again next one, 480 minus 550, if you subtract it both one, it will becomes to minus 70, minus 70 also, minus 70 square, 4490. Again the 380 minus 450, 380 minus 450, it will also becomes to minus 70, minus 70 square, it will be 4900. So 520 minus 450, again which is 70 square as 4900. Okay, now so now we need to observe minus X factor square divide X factor. Okay, X factor. So if you do the cases, 4900 divide X factor 550. Clearly the 10 will get cancelled. Here also we could cancel by 5 table, which is 11 time in 49. 9 times of 5, remaining 40, that is 8 times of 5. We could get 98 divide 11. Again, which is also the same case only, 98 by 11. So next one, 4900, 450. Again 10 we get cancelled, which is also we can divide by the 5 table, 9 times of 5, which is 49, 9 times of 5, remaining 40, which is 8 time, this is 9811, which is also 9811. So if you calculate the value, if you divide it, after we calculate the value, it will become, which is a 9, 98 by 9, which is also 98 by 9. If you calculate the value, it will becomes to, the answer is a B. So you can use a calculator, we can able to find the chi-square, sum the value. Here asking the value something only the chi-square value. Chi-square is nothing but the formula already we knows. It will be chi-square equal to sigma observed minus X factor square divide X factor, sum of the value. We need to add all value. If you add the all value, finally if you take this using with the calculator, if you add the value, we can get the solution is nothing but B. The same manner it will be also discussed. Okay, the two groups of 100 peoples each were taken for the testing the use of the vaccine. 15 persons contracted the diseases out of the inoculated persons, while the 25 contracted the diseases in the other group. Test the efficiency of the vaccine using chi-square value at 1% level. But if we given the percentage of 1%, the previously all problem we discussed in the 5% level. So what is the previous problems on this one? The difference nothing but previous all problem the contingency matrix is given, but in this cases the contingency matrix is not given. So we need to check. Okay, first one we need to create the contingency matrix, and then we need to go and find what is the result will be possible. Okay, now so how to find it will be chi-square. One is directly be given chi-square. Okay, so one is given directly to be chi-square. One is given the directly chi-square, and another way we could find the attributes. The attributes are nothing but be given the two cases of the attribute. So two group of 100 people each were taken for testing the uses of vaccine. Vaccine is nothing but one cases of the 15% contracted the diseases out of the inoculated persons, while 25 contracted the diseases in the other group. Okay, no. So the vaccines will be contracted of the inoculated. Okay, no. These both are the two attributes. Okay, no, so we could be able to do. So I'll be creating the table. Okay, no, using the previous problem, you can also get the solution. So first one, affected, not affected is nothing but contracted, this will be meaning something but affected, inoculated, not inoculated, which is total, okay. So the two groups of 100 peoples each. So each group should be 100 peoples taken for testing the use of vaccine. 15 persons contracted, affected 15 persons. Since the 15 persons affected means the remaining person from the 100 will be not affected. Therefore, it becomes to 85. Because each group is nothing but 100, first group 100, therefore first total 100, second total also be 100. Okay, this is a group. One is nothing but inoculated group, another one non-inoculated group. So the each group is 100, that's why I pictured beginning 100 in this total, both one. So affected, contracted as a 15%. So 15% contracted means, affected means not affected 85%. So as well as the while 25 contracted in the diseases in the other group. Other group means not inoculated group, that is other group. Therefore 25 affected means remaining 75 not affected. So sum of the 15 plus 85 is 100, sum of 25 plus 75 will also be 100, that is a row total, so it becomes to 200. So already we know that the consistency matrix should not be satisfied, row total and the column total both are to get the same frequency. Therefore 25 plus 15 which becomes to 40, 5 plus 5 10, okay, it will becomes to 10, 8 plus 7 it will be 15, it will be 160. So clearly 160 plus 40 both will be 200. Okay, now we have the position again, it will be also 2 by 2 consistency matrix. Already you know how to find the 2 by 2 consistency matrix. So now we have the observed value. Okay, 15, this is the position of A, this is the position of B, this is the position of C, this is the position of D. Okay, like us we discussed previously. Therefore now we have the observed one. Okay, so to the observed one corresponding we can get expected frequency. Using by the expected frequency and observed frequency we can get the value. Okay, observed frequency, expected frequency, observed minus expected square and observed minus expected square divide expected. Okay, finally we can get the table value. Okay, chi-square equal to summation of observed minus expected whole square divide expected. Okay, so after getting in this value of the chi-square, it becomes a table value. So clearly, which is a 2 row and 2 column, the degrees of freedom is nothing but 1 for the 1% level. If you check it, okay, using the previous concept, we can get it be the vaccine is not affected. Okay, that is a H0 is accepted. So final solution will be get H0 will be accepted. We thank you. We will see the next session.